Permit requirements for electrical work are not uniform across the board. What is required in one municipality might not be in another. Therefore, the most reliable course of action is to directly contact your local building department. They are the definitive source for the specific regulations in your area. Many jurisdictions mandate permits for virtually all construction and electrical projects, irrespective of the financial investment. This means even a small job, such as replacing a light fixture, could technically necessitate a permit. However, some municipalities do institute a minimum cost threshold. Projects falling under this threshold may be exempt from the permit requirement. This threshold is not standardized and can differ significantly. For example, a city might waive permit requirements for projects valued under $500, while another might set the limit at $1,000. It is absolutely crucial to understand that even if a permit is not legally mandated due to the project's size or cost, adherence to all relevant building codes and safety regulations remains paramount. These codes and regulations are in place to safeguard life and property. Neglecting them, even on a small project, can have serious consequences, including fires, electrical shocks, and structural failures. Ignoring these rules can also create significant liability issues. If substandard work leads to an accident or injury, the property owner could be held responsible, even if they hired a contractor. Furthermore, shoddy electrical work can negatively impact property value and potentially create difficulties during a future sale. When unsure whether a permit is necessary, it is always best practice to err on the side of caution and contact the local building department. Building departments typically have websites or phone numbers readily available to answer such queries. They can provide specific guidance tailored to your project and location. It is important to provide them with a clear and concise description of the work you intend to perform, including the scope and estimated cost. When contacting the building department, be prepared to answer questions about the project. They may ask about the existing electrical system, the type of work being performed, and the materials being used. They might also require you to submit plans or drawings for more complex projects. Understanding the local electrical codes is also important. Electrical codes are a set of regulations that govern the safe installation and maintenance of electrical systems. These codes are designed to protect people and property from electrical hazards. In the United States, the National Electrical Code, or NEC, is the most widely adopted electrical code. The NEC is updated every 3 years to reflect changes in technology and best practices. Some states and municipalities may adopt the NEC with amendments, meaning they make changes to the code to better suit local conditions. Therefore, it is important to understand the specific electrical codes that are in effect in your area. Even if you are not required to obtain a permit, you may still be required to comply with the electrical code. Familiarize yourself with common electrical safety practices. This includes things like turning off power before working on electrical circuits, using the correct type of wire for the application, and properly grounding electrical equipment. You should also know how to identify and correct common electrical hazards such as frayed wires, loose connections, and overloaded circuits. Consider taking an electrical safety course. Many community colleges and vocational schools offer courses on electrical safety for homeowners and do-it-yourselfers. These courses can teach you the basics of electrical safety and help you avoid common mistakes. When in doubt, hire a qualified electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. A qualified electrician has the training and experience to safely and correctly perform electrical work. They will also be familiar with the local electrical codes and permit requirements. When hiring an electrician, be sure to check their credentials and references. Ask for proof of insurance and licensing. Get a written estimate before the work begins and make sure that the estimate includes all labor and materials. The NEC Article 90.2 covers the scope, which includes the installation of electrical conductors and equipment, signaling and communications conductors, equipment, and raceways, optical fiber cables and raceways, and installations in buildings, structures, and other premises. The NEC also covers installations of conductors and equipment that connect to the supply of electricity, installations in yards, parking lots, and other outside areas, installations for specific occupancies such as healthcare facilities, and installations for specific equipment such as elevators and escalators. It's important to note that the NEC is not intended to be a design specification or an instruction manual. Instead, it provides minimum requirements for electrical safety. Design and installation practices that exceed the NEC requirements are permitted, as long as they do not create a safety hazard. Furthermore, the NEC does not cover all electrical installations. For example, it does not cover the installation of electrical equipment in vehicles or aircraft, or the installation of low-voltage communication systems that are not connected to the power grid. Other codes and standards may apply to these types of installations. The permitting process typically involves submitting an application to the local building department. The application will require information about the project, such as the scope of work, the location of the project, and the estimated cost. The building department may also require you to submit plans or drawings of the project. Once the application is approved, you will be issued a permit. The permit will typically have an expiration date. It is important to complete the project before the permit expires, or you will need to renew the permit. The building department will typically inspect the project at various stages to ensure that it is being completed in accordance with the building codes. If the project fails inspection, you will be required to make corrections and request another inspection. Once the project passes final inspection, you will be issued a certificate of occupancy. The certificate of occupancy is proof that the project has been completed in accordance with the building codes and is safe for occupancy. Even without a permit, consider a professional inspection. Once the electrical work is complete, you might consider hiring a qualified electrician to inspect the work, even if a permit wasn't legally mandated. This provides an extra layer of assurance that the work was done safely and correctly, adhering to code standards. The electrician can identify any potential hazards or code violations that you might have missed. This is especially valuable if you are not experienced in electrical work. This inspection can provide peace of mind and documentation that the work was performed responsibly. Furthermore, it can be helpful if you ever sell the property, as it demonstrates that the electrical system was inspected by a professional. It is important to understand the distinction between a homeowner's insurance policy and a contractor's insurance policy. A homeowner's insurance policy typically covers damage to your home caused by events such as fire, wind, and water damage. It may also cover liability for injuries that occur on your property. However, a homeowner's insurance policy typically does not cover damage caused by faulty workmanship or negligence. If you hire a contractor to perform electrical work, you should make sure that they have their own liability insurance. This insurance will protect you from liability if the contractor's work causes damage to your property or injures someone. Additionally, you should verify that the contractor carries workers' compensation insurance, which protects you if a worker is injured on your property. Electrical codes often specify the types of wiring methods that are permitted for different applications. For example, non-metallic sheath cable, often referred to as Romex, is commonly used for residential wiring. However, it may not be permitted in certain types of buildings or in areas where it is subject to physical damage. Electrical metallic tubing, or EMT, is another common wiring method. EMT is a thin-wall steel conduit that is used to protect wires. It is often used in commercial and industrial buildings. Rigid metal conduit, or RMC, is a thick-walled steel conduit that provides a high degree of protection for wires. It is often used in hazardous locations or where wires are subject to severe physical damage. It's important to select the appropriate wiring method for the application. Using the wrong wiring method can create a safety hazard. The NEC, specifically Article 310, outlines the requirements for conductors for general wiring. It details the allowable ampacities of insulated conductors rated up to 2000 volts, nominal. Ampacity refers to the maximum current, in amps, that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. This article provides tables such as NEC Table 310.15b16, which lists the ampacities of various conductor sizes and types based on factors like insulation, temperature rating, ambient temperature, and a number of conductors bundled together. Understanding these tables is crucial for selecting the correct wire size for a given circuit to prevent overheating and potential fire hazards. The NEC also mandates specific requirements for grounding and bonding. Grounding refers to connecting electrical equipment to the earth, which provides a path for fault current to flow back to the source. Bonding refers to connecting different metal parts of an electrical system together to create a low impedance path for fault current. Proper grounding and bonding are essential for preventing electrical shock hazards. When a fault occurs in an electrical system, such as a short circuit, the fault current will flow back to the source through the grounding and bonding system. This will cause the circuit breaker or fuse to trip, which will interrupt the flow of current and prevent an electrical shock. The NEC requires that all metal enclosures for electrical equipment, such as panel boards, junction boxes, and motor housings, be grounded. It also requires that all metal piping systems, such as water pipes and gas pipes, be bonded together. This helps to ensure that there is a low impedance path for fault current to flow back to the source. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electrical shock. A GFCI monitors the current flowing in the hot and neutral wires of a circuit. If there is a difference in current between the two wires, it means that some of the current is leaking to ground. This could happen if someone touches a live wire or if there is a fault in an appliance. The GFCI will quickly trip the circuit, interrupting the flow of current and preventing an electrical shock. The NEC requires GFCIs to be installed in certain locations such as bathrooms, kitchens, and outdoor areas. These are areas where there is a high risk of electrical shock. It's important to test GFCIs regularly to make sure that they are working properly. You can test a GFCI by pressing the test button on the device. This should trip the circuit and cut off power to the outlet. If the GFCI does not trip when you press the test button, it should be replaced. Arc fault circuit interrupters, or FSIs, are another type of circuit breaker that can help to prevent fires. An FSI detects arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur when wires become frayed or damaged, or when connections become loose. The FSI will quickly trip the circuit, interrupting the flow of current and preventing a fire. The NEC requires FSIs to be installed in certain locations, such as bedrooms and living rooms. These are areas where there is a high risk of arc faults. It's important to understand the difference between a circuit breaker and a fuse. Both circuit breakers and fuses are designed to protect electrical circuits from overcurrents. However, they work in different ways. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then has to be replaced, a circuit breaker can be reset either manually or automatically to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect entire high-voltage power systems. A fuse is an overcurrent protection device with a circuit opening fusible part that is heated and severed by the passage of overcurrent through it. A fuse is a one-time use device. Once it blows, it must be replaced. Fuses are typically less expensive than circuit breakers, but they must be replaced each time they blow. Circuit breakers are more expensive, but they can be reset and reused multiple times. The proper selection of overcurrent protection depends on the application and the specific requirements of the electrical system. It's important to use the correct size circuit breaker or fuse for the circuit. Using a circuit breaker or fuse that is too small will cause it to trip or blow prematurely. Using a circuit breaker or fuse that is too large will not provide adequate protection and could lead to a fire. When working with electricity, it is important to follow all safety precautions. Always turn off the power before working on any electrical circuits. Use insulated tools and wear rubber gloves. Never work on electrical circuits when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified electrician. Remember, safety is always the top priority. Neglecting to follow safety precautions can have serious consequences, including electrical shock, burns, and even death. Even seemingly minor electrical work can pose significant risks if not performed correctly. It is always better to be safe than sorry. Always contact your local building department to determine the permit requirements for your project. Always follow all building codes and safety regulations. And when in doubt, hire a qualified electrician.